Hello, y'all, and welcome back to Learning with Jelly. So, today we're going to talk about the sixth video in our Python for Fundamentals series, a series meant for you to have some fundamentals down packed before we go into statistics concepts, data analytics, and data science concepts. And today it's going to be all about the Pandas library in Python. So, I have a cute little panda up here. I actually personally love pandas, I think they're so adorable. So hopefully you'll love pandas too and figure out how useful they will be in a data analytics or data science career. So what are our objectives for today? The pandas library, why should you care in the first place? What is this library used for? We're going to read in some data as a data frame. So this is probably going to be one of our most exciting fundamental videos because you actually get to read in data. And with that data frame, we're going to explore it. So, data exploration is very, very, very necessary in data analytics and data science. You don't model your data until you know what's in it. Okay. So, why should we care? How is Pandas used in data science? Okay. It is one of the go to libraries for data cleaning and data preparation, which is 60 to 80% of most data science jobs. So, you're going to 99% of the time get a job where you're going to have to clean the data, explore the data, and prep the data for modeling. Okay. It has this data frame object type. And this object type makes it easier for data analysis and modeling down the road than just standalone arrays. Okay. So, the previous lesson, we talked about the NumPy library, and that NumPy library has those arrays in it where we can manipulate arrays. It has a lot of mathematical functionality. We're also able to generate distributions. But Pandas is going to be built off of the NumPy library to add this dynamic data frame object type. That's very, very useful to store our data and to analyze our data. And it is also very useful for exploratory data analysis, which needs to happen first. So, this is a good example of a data frame, right? And having our data in this nice format is going to allow us to explore and analyze our data that much more easier than just standalone NumPy. Okay. So, what is Pandas? It's a powerful data analytics tool or library that's built on top of NumPy. It's used, like I've said previously, for data wrangling, data cleaning, and it can also be used to read in data files, CSV files, text files, Excel files, etc. Okay. So, this is a very, 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 very popular library that you're going to have to know. All right, so now let's read in some data. Okay. So last tutorial, we talked about importing the NumPy library as the alias NP. And now we're going to talk about importing pandas as PD. Okay. So we're going to import the pandas library. We're going to read in some data, and we're also going to explore this data. So I'm going to read in some King County data, which is just sale price of homes. Okay. I'm calling it data slash king underscore county dot CSV. You too will have access to this data. I'm going to link my GitHub repo down below. And when you go to this repo within Python fundamentals, there's this data folder. And inside of that data folder, it has some King County data that you can work with. Okay. So you definitely can follow along and have access to the same data that I do. It's in the data folder. So that's why data is coming first. Then there's a forward slash with the actual file name. Okay. So I'm going to read in this data file. All right, so after we read it in, we now can explore the data. And so I'm going to teach you some common methods and attributes that you can do on data frame objects. So I stored in that real estate data, and let's just go back one briefly. I stored in that real estate data as the object DF. So now if I do type of DF, it should say that it's a data frame, and it's a data frame. So the next methods and attributes I'm about to show you are specific to data frames only. Okay. So if you have an array, you need to convert it to a data frame if you want to use the following methods and attributes. Okay. All right. So we have a data frame called DF. Awesome. Now, the first method that you're going to learn, and methods are pretty easy to spot because it's a function. So, this is what you can do to the data frame, right? Just like I can run, I can walk. That's a method, but an attribute is more of a characteristic about myself. Jelly has black hair. Jelly has big eyes. Okay. So attributes are characteristics, methods are more like verbs and actions, and methods normally have a parentheses that follow the method. So I have my object data frame and I'm calling the dot head parentheses method. And this is going to give me the first 5 rows by default of my data frame. So I see that I have the ID column, I have the price column, bedrooms, etc. So this gives me a quick look at what data am I working with, okay? If you don't want the first 5, you can put a 10 in here and it will give you the first 10. All right? So I can look at the head of my data to see what's at the top. So that means that I can also look at the bottom of my data with the dot tail method, and I get the 5 bottom rows as well. Okay. Outside of looking at the top or bottom of my data, I can do a dot info, and I love dot info. It tells me what columns I have, what the data types are in my columns, how big my data set is, and if I have any missing values. So this is my go-to. So I see I have 21,613 entries, which means I have about 21,600 rows, and I have a total of 13 columns. It has the column names and the corresponding column index. So, say for instance, I want to call on a column by its index and not its actual name. It's going to tell me how many non null values I have. So, if I have 21,613 rows and I have 21,613 IDs, that means there's no missing values for ID. Okay. It also tells me the data type. So all of my IDs are integers. My price is a float, etc., etc. And I can also see something in here if it was an object data type. And it's important to know your data types because, as I mentioned before, what you can do to objects, you can't do with integers, and then vice versa. So this gives me an overall feel of the types of columns, if I have missing values, and what the data types are inside my column. All right, so dot info is another method that you can use. For summary statistics, you can use dot describe, which I also love. It's going to tell you the mean, standard deviation, minimum, 25th percentile, et cetera, et cetera. So this can give you a quick look at the spread of your data. So if I'm looking at bedrooms, on average, there's a little over 3 bedrooms in my data set. There's some houses that have no bedrooms in my data set, and some houses that have up to 33 bedrooms in my data set. So is it an outlier? Is it a typo? Is there really a house with 33 bedrooms? These are things that you can look at just by looking at some summary statistics using the dot describe method. You also have the attribute of dot shape, which can tell you how many rows, how many columns. So we already know there's about 21,613 rows and there are 13 columns. Okay. That is something that we also can get from the dot info, but this is just an example of an attribute. Notice my attribute did not follow with parentheses. And I also can get a dot columns attribute as well. And it's going to list out the columns for me. So maybe I want to copy and paste a column name, and this may be easier than just looking at dot info below. But pretty much these two attributes will pop out with the info method. All right. So these are some common methods and attributes of data frames where you can explore your data to figure out what's in your data, what's the spread of your data, if there are missing values, et cetera, et cetera. So not only can you have those methods and attributes available for you, you also can filter your data frame pretty well. Okay. So I'm using this dot loc. Okay. And this dot loc is going to be able to filter my data frame where bedrooms are greater than or equal to 4. So when I run this, I see that all of my bedrooms in the bedroom column are for bedrooms that are greater than or equal to 4. So say for instance, I only care about looking at those houses that are family houses for families of 5 or more. So I can do a filtering, and that's what the dot loc is. It's for label location. So when you call dot loc, you have your brackets, you have the name of the column that you want to look for, and you have your condition. Okay. Outside of dot loc, you can do iloc, which is index location. So in this case, I put in numbers. So say for instance, I only want to look at certain rows. In this case, I want to look at row 0 to 15, and I get my rows out. Okay, it's going to be up to, but not including the last number. That's why it ends at 14. All right, so I can also filter using iloc, where I'm going to pass in numbers or the indexes of the observation or the columns instead of the actual name itself. And I can also get correlations with pandas. And this is very powerful to see how my predictors are associated with one another. Okay. So this is the dot core method. And within this dot core method, I get all of my columns on the left as well as above. And it tells me how strong or how weakly associated they are. Now you're going to have one straight across on the diagonal because ID is always perfectly correlated with itself. Correlation for this case is the Pearson R correlation, and it's on a range from -1 to 1, whereas -1 is strongly negatively correlated and 1 is strongly positively correlated. And I can kind of do a quick search to figure out what's correlated. So I see in this case, bathrooms and square foot living have a high positive association with one another. Okay. Maybe the more square feet you have, the more bathrooms you're allowed to have in your house, which makes very, very good sense to me. Right. Let's see if we can poke out another one that is negatively associated. So let's just scroll over to see if we have any that stand out for us. I don't see any that stands out crazy from that. Okay, but for instance, I see that floors is weakly positively correlated with price as well. Okay, the grade looks like it's strongly correlated with price. So, this can give you all of your associations with each other as well as with your prediction, which is price or your predictor variable. Okay, so dot core is very, very, very powerful. Okay. So, you have learned a lot from Panda so far, and you got a chance to read in and play around with the data frame, which I always love to do. Okay. So, the things that I want you to know is the library. You need to make sure that you import the library. Pandas can read in data files, CSVs, text files, Excel files, etc. Within Pandas, there's a lot of methods and attributes that you can do to explore your data. Okay. You can look at your data. You can get summary statistics of your data. You can see if there's missing values in your data. You can see your columns and their data types. There's so much that you can do. Okay. So I hope that this was a beneficial tutorial. Please like, comment, and subscribe, and I'll see you in the next fundamentals lesson. Bye bye.